we are making our way well through chapter 5. We are on section 5-6, and I think we only have one more section to go before our test. So let's take a look at chapter 5-6 today, or section 5-6 rather. We're going to talk about geometry, the idea of parallel lines and perpendicular lines. So our vocabulary is basically those two concepts, parallel lines and perpendicular lines. Parallel lines, I hope all of you are familiar with, are lines that are in the same plane that go in the same direction. Let me see if I can get my computer to cooperate with me. There we go, that's a little better. So here we have two lines that are parallel. They're going in the same direction, and if I draw them right, you would be able to observe that these two lines will never ever intersect. They're in the same plane. Right now we're looking at the plane. When I talk about plane, I mean like I'm talking about like on a flat plate in a way, or in a flat space or a flat sheet of paper, in a way you can think about the plane of my computer screen, right? Or your computer screen as it is. And so these two lines are going in the same direction, and sometimes you might see additional little arrowheads that indicate that those two lines are parallel. So that's a parallel line situation. Perpendicular lines are lines that intersect, first of all, so they're definitely not like parallel lines. They intersect, that means they cross each other, but they must cross each other in a very specific way. And that specific way is that they form a 90-degree right angle with each other. So parallel lines, just to reiterate, are lines in the same plane that are parallel, that run alongside each other or run in the same exact direction and will never intersect, whereas perpendicular lines are lines that do intersect. They cross each other, and in fact they must cross each other in a 90-degree angle. And so that is our vocabulary. Let's begin a couple of examples. Let's take a look at example 1. Here we are. We're looking at parallel line through a given point. So we're going to write the slope-intercept form of an equation for a line that passes through point -1, -2, and is parallel to the graph of y equals -3x minus 2. Woo, a lot going on here. Let's see if we can break it down. First of all, we're talking about parallel lines, and we remember parallel lines, actually I didn't say this before, I just kind of defined it before. Let me go back real quick, my bad. Parallel lines, let me add a little bit. Parallel lines have the same slope. Should have told you this. Parallel lines have the same slope, which kind of makes sense. The up and over that I do here has to be the same up and over that I do here. Does that kind of make sense? So parallel lines, when we talk about it from an algebraic perspective, have the same slope. So if the slope of one is a over b, the slope of the other is a over b. Got me? All right, so parallel lines have the same slope, whereas perpendicular lines have slopes that are, this is going to sound crazy, opposite reciprocals of one another. Or, I'm going to say something else that's going to sound even crazier. Their slopes, when multiplied together, will always give you -1. Let's see what I mean. So the slope of one line, let's say, is a over b. The slope of a line perpendicular to it, this upside down T, is the symbol for perpendicularity. The perpendicular slope to something that has a slope of a over b is going to be negative. Look at the change of sign. The signs are opposite, reciprocal. Flip it. A over b is the slope of one line, and the slope of its perpendicular line would be -b over a. Now, how does that work? In terms of what I said when you multiply those two slopes together, you're going to get -1. And as you see, if I multiply two reciprocals to one another, these guys cancel out, these guys cancel out, and I'm left with -1. Or you could see AB over BA and negative pi, blah, blah, blah. Hopefully that made sense with my blah, blah, blah. If it does not, let me know. We can talk about it. So this information we're going to take with us as we do the example. So now let's get down with example 1. Here in example 1, we want to find, we're looking for slope-intercept form, so I like to start off by writing out the form that the text or that the teacher or whatever wants me to do it in. I want it in slope-intercept form of a line, and I want it to pass through this point, and I want it to be parallel to this line. All right, it's got to pass through this point parallel to this line. If it is parallel to this line, then we know it has the same slope as this line. Can you identify what the slope is of this line? Hopefully by now you can see that this is in slope-intercept form, and indeed you can identify the slope. The slope is right there, and it's -3. So now I know that the slope of the line I'm looking for, m equals -3. Sometimes I say this to students and they giggle and they think I'm being crazy. That is all you need of this equation. You ain't got to touch this -2, none of that stuff. The only thing you needed to do is use this equation for its slope. After you got its slope, you walk away. Don't fool around with this anymore. So now I'm in a situation where I have a point and a slope. And I've got the point that this line passes through and the slope of the line. You remember from the last exercise, you know how to find the slope, the equation of a line with point and slope. We can use point slope form. I know right now you're saying, but hey, Miss D, aren't we supposed to use like y equals mx plus b? I'm going to show you a way to do this. Since they gave us the point, and we found the slope pretty easily, we're going to use point slope form and then change it into that. So y minus the y term, -2, is equal to m, -3, times x minus the x term. Okay, so this is, remember, I'm quickly going to use point slope form, and then I'm going to morph it into that form, because I think in this case that might be the easiest way. We'll do it two ways just because I feel like you want to do lots of math today. So y plus 2 is equal to -3 times x plus 1. Are you still with me? Next thing I'm about to do, because remember I want it in this form, I need to free this stuff in parentheses by multiplying through, doing a little distributive property. Y plus 2 is equal to -3x minus 3. And then finally I'm going to take it home by subtracting 2 on both sides. And look at how gorgeous this is. Y is equal to -3x minus 5. I'm going to stop there and box it. So this is definitely one path to answer this question. Notice what we did. We found out that the line had to be parallel to this guy. We knew that it had to be the same slope. They gave us a point. We used point slope form. We used point slope form and metamorphosized it back into slope intercept. I'm going to now not do that. I'm going to do the same problem, and I'm going to say, okay, let me take slope intercept form. I'm going to plug in the slope x plus b, and now I'm just going to find b. To find b, I've got to use this point for x and y in order to solve for b. So if I use the point is -2, right? Plugging in the y term of the point, then I'll plug in the x term of the point, and then I'll end up finding b. Well, this isn't too bad. -2 is equal to +3 plus b. I'm going to solve for b by subtracting 3 or adding a -3 to both sides. I get a -5 is equal to b. And so I'm not done yet, but now I know what b is. I know what m is, I know what b is, and now I'm going to just put them together. And so I have a -3x minus 5. You can do these problems in either of these ways. Both are fine, but I just don't want you to feel like you are stuck and there's only one way to get through it. I hope that made sense. Let's try another. We are in example 2, and we're going to determine whether lines are perpendicular. Now, we remember that perpendicular lines have the quality that their slopes are going to be opposite reciprocals of one another. I'm going to bring up my little thing that we talked about. So if A over B is a line, then the line that is perpendicular to it will have a slope of -b over A. If A over B is the slope of a line, then the line that is perpendicular to it would have opposite sign and flip it. Opposite and flip it. Okay, so the outline of a kite is shown over here. Determine whether AC, that's this segment here, is perpendicular to BD. Well, the simplest way to do it is to figure out what the slope of each would be. So the slope of AB is what I'm going to find out. The slope of AB, I'm going to push MAB. The slope of AB is going to be equal to, well, let's see, is it AB? Oh, no, AC, darling. My bad. Thank you for correcting me. You were started getting nervous. I understand. The slope of AC, thank you, is going to be given by y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And I'm going to just do 5 minus 1 and 5 minus 7 as my numerator and denominator, and what I get is a positive 4 over negative 2, which is negative 2. So I could look at this as a negative 2 over 1, and now let's find the slope of DB, or BD. So the slope of BD is going to be change in y over change in x, so I'm going to do 4 minus 0 over 8 minus 0, okay? 4 minus 0 over 8 minus 0, and I get 4 over 8, which is 1/2, and woohoo! These guys are opposite reciprocals of one another. When I multiply them, I get a negative 1, so indeed they are perpendicular. So AC is indeed perpendicular to BD, and that's how you would write that when you're a geometry student, all right? Here in example 3, we're going to find a perpendicular line given a point. So we're going to write the slope-intercept, and remember slope-intercept looks like this. The slope-intercept form of a line for an equation of a line that passes through this point and is perpendicular to this equation, to this line. So what I'd like to do is find the slope. To find the slope, if I can figure out the slope of this, then I know how to relate a perpendicular slope. So how can I find the slope here? What I'm going to do is put it in the slope-intercept form, right? So if I say 4y, x plus 4y is equal to 12, I'm going to subtract x on both sides, because remember, in order to find the slope, it might be really nice for me to put this in slope-intercept form. Does that make sense? And now remember, slope-intercept form is y equals mx plus b, as we're going to try to do over here. I'm just putting this line in it so I can find the slope, right? I'm putting this line in that form. I'm going to divide everything by 4. And y is equal to, watch me now, 1/4 x plus 3. Notice I'm dividing each of these terms by 4. I'm going to write this a little neater for you. So I worked really hard to solve for y, put this equation in slope-intercept form so I can find the slope. So the slope of this line is negative 1 over 4. The slope of this line is perpendicular to that. So I know that the slope of the perpendicular line has to be reciprocal, change sign. So the slope of this line that I'm looking for is going to be 4. Got me? Right? Flip it over, 4 over 1, and change the sign. So now that I have that, I'm going to solve the equation by just saying y is equal to 4 times x plus b. Remember, to find the equation of a line in slope-intercept form, I need to have m and b. So to get b, I'm going to plug in these 2 points, or these 2 values, these 2 ordered pairs that refer to this point xy. I'm going to plug the negative 2 in here, equals 4 times negative 3 plus b. I get a negative 12 is equal to negative 2. There we go, and move this over here. Positive 12 being added on both sides gives me 10 is equal to b. Is that all right? And so now that I've got m and now that I've got b, I know that the equation of the line, drum roll please, is 4x plus 10. All right? Remember, I just used this little equation to figure out what its slope was. Use its slope to figure out what my slope was. In this case, our slope was perpendicular. You know, you could solve this problem a different way, but this way is totally justified and fine. Let's move on to another example. This equation, this one is very similar to the last one, except it adds a little bit of a twist to it because they didn't actually give us a point. It says write the slope-intercept form of a line, right, of an equation of a line that passes, that is perpendicular to this and passes through the x-intercept of the line. So this thing is the point that I'm looking for. So the point is the x-intercept. Well, the slope of this line is pretty simple. It's negative 1 over 3. So if the slope of that line is negative 1/3, then the perpendicular slope is going to be 3 over 1 positive 3. So I'm already part way there. So I've got y equals 3x plus b. Now I got to figure out how to get the b, but they're asking me to find the x-intercept of this line. We haven't done as much work with this as I would like, but to find the x-intercept of a line, the x-intercept is the point that looks like this. X and then the y term is 0. So the x-intercept is when the x term is a value and the y term is 0. So what that means is plug in 0 and solve for x. When I do that, I get that x is equal to 6, and that means that the point we have is 6, 0. So now I'm going to use that point to finish off my problem. Plugging in 6, 0, I get simply that 18 plus b is equal to 0, therefore b equals negative 18. Our equation is y equals 3x minus 18. If you have problems with any of this,